Guys, it is me. I am doing a super quick video to try and help clear up a little bit of confusion about today's lesson. Today's Wednesday. So we're focusing on multiplying a fraction times a whole number, and Mr. Ritchie called them hunky-dory, meaning that everything kind of worked out evenly. But today's lesson is what happens if that doesn't happen. So I'm going to go ahead and kind of summarize what Mrs. Wolf was saying, and hopefully it makes a little bit more sense if you were struggling. I think one of the reasons that it's hard for you is we never covered multiplying a fraction times a fraction. So I just want to show you real quick what a fraction times a fraction is. It's actually really easy to do. If I have like 1/3 times 2/5, when you're multiplying a fraction times a fraction, you simply take the numerators and multiply them together to get the new numerator. 1 times 2 is 2. And you multiply the denominators together to get the new denominator for your answer. 3 times 5 is 15. Now, we're not going to focus. Now, in the classroom, we did everything is simple. Everything is simple when you draw an F. We always wanted to have our final answer in simplest form. I'm not going to require that because it's a lot. If you did want to do it, though, take it to the next level. Remember, we were doing simplest form with the F, putting it in simplest form. And we know we're in simplest form when we're 1 and done. I don't see a numerator of a 1. I'm not 1 away with the numerator and denominator. So I'm going to list the factors of 2, 1, and 2. And I'm going to find the greatest common factor that 15 also has. Well, there's nothing times 2 that makes 15, so that doesn't work. And you can see I'm 1 and done. So the final answer here would be 2/15. Now, that is how you multiply a fraction times a fraction. Well, we hadn't covered that yet. And so without knowing that, it might make Mrs. Wolf's video a little bit confusing. Now, Mrs. Wolf's video is not showing a fraction times a fraction. It's showing a fraction times a whole number. But what she was saying is you can actually rewrite a whole number as a fraction. You can rewrite this as 21 over a denominator of 1, because this just means 21 divided by 1, well, which is 21. So we've turned this fraction times a whole number problem into a fraction times a fraction problem. So I'm just going to rewrite it. 2/5 times 21 is our numerator, 1 is our denominator. And we end up with, now we have the numerator times the numerator, 2 times 21. If you need to set up a separate problem for that, great. 2 times 21 is 42. And to figure out the denominator, 5 times 1 is 5. Now, this is where some of you guys were getting confused because we had covered turning a, I'm going to move this up here. We had covered turning a improper fraction, which this is, into a mixed number. But we didn't do it the same way that Mrs. Wolf did it. We started out by using pieces. You grab the fifths bucket in this case, and you pull out 42 fifths. And our job is to figure out how many wholes we can make with those 42 fifths, and then how many fifths would be left over. That's why the denominator never changes. So she was setting up a division problem, but really you don't really need to do that. You can, because that's what we're going to be doing in our head. We have 42 fifths in our hand, and we know that we're dividing them into groups of 5 because 5 fifths makes a whole. So our job is to figure out how many groups of 5 can we make out of 42. In other words, 5 times what is going to get me as close to hitting that target of 42 as possible. Whoa, I deleted way more than I wanted to there, didn't I? Let me put that box back there. So I know that 5 times 8 is the closest I'm going to get to 42. It's going to get me to 40. And that means I've used up 40 out of my 42 fifths. Well, how many fifths do I have left? Well, I have 2 fifths left. So my final answer, maybe, is going to be 8 and 2 fifths. Now, I will accept that as an answer. But remember, I always said to you, is this your best possible answer? If it's an improper fraction, which in this case it was, we needed to turn it to a mixed number, which we did. But then we can check and make sure our answer is in simplest form. Are we 1 and done? Now, we can't see 1 and done with our eyeballs. There is no numerator of a 1. They're not 1 apart. So I would need my greatest common factor to be a 1. This part is going to be optional because I know that just the improper to mixed is a lot of work, but again, you list the factors of 2. We're looking to see if there's a factor that will also work for 5 besides 1, so we can knock it into its simplest form. But I know there's nothing times 2 that makes 5, which means we are one and done. So the 2/5 part of my answer is already in simplest form. So the final answer of the original problem, remember the original problem was 2/5 times 21 is 8 and 2/5. Okay, I know this is a lot. We're going to do another one. Okay, 1/4 times 19. So I'm going to go ahead and say, okay, I don't know how to do a fraction times a whole number, but I do know how to do a fraction times a fraction. I'm going to rewrite this whole number as the fraction 19 over a numerator of 1. They mean the same thing because this is 19 divided by 1 is still 19. So I'm going to set this up 1/4 times 19 over 1. And I'm going to multiply the numerators to get my new numerator. 1 times 19 is 19. And then multiply my denominators to get my new denominator. 4 times 1 is 4. Now, again, we have our IS checklist. Is this the best way to say my final answer? 19/4 is the answer, but it's just not I'm really wobbling my screen here. It is not the best way to write that answer. So the first thing we're going to do is say, is this answer an improper fraction? It is absolutely improper. So we're going to change that improper fraction into a mixed number, what we're going to do first. So let's think about what this means. I have 19/4. So I grab my bucket of fourths and I'm going to pull out 19 of them. And obviously, if I have 19/4, I can put some of them into wholes, but then I'm going to have some fourths left over. And that's why my denominator of my mixed number is going to stay the same. So here's what I'm going to do. I'm going to go ahead and change my colored pen here and say, okay, I have 19/4, and I want to put them first into wholes. Well, I know it takes 4/4 to make a whole. So I'm going to take these 19 and divide them into groups of 4. How many groups of 4 can I make? Well, we like to use the mystery of multiplication for division. So instead, I'm going to say, okay, 4 times what is going to get me close enough to use those 19 fourths that I have? Well, I know, oh, I did it again. I know, you think I would learn from my first mistake. I know that 4 times 4 is 16 and 4 times 5 is 20. I don't have 20 fourths. I only have 19. So the best I'm going to get is 4 times 4. That's going to use up 16 out of my 19 fourths that I have. And so I didn't use them all. I have some fourths left over. If I use 16 and I had 19, I'm 17, 18, 19. I'm 3 away from using all 19. So I have 3/4 left. So my original answer was 19/4. I changed that to something that makes more sense because according to our IS checklist, I need to make sure that my answer makes the most sense to people. And so I successfully turned that improper fraction into a mixed number. I'm going to check and see if I'm in simplest form. If I am, great. If I'm not, I might make this answer easier for people to understand by putting the fraction part in simplest form. We know that's one and done. And you can see with the fraction 3/4, the numerator and the denominator are 1 apart. So I'm 1 and done. Your final answer here would be 4 3/4. Okay, I'm going to do one more example. Holy moly, I wrote really big for this one. So we have 4/10 times 7. So the first thing I'm going to do is I'm going to rewrite this. 4/10 times. And instead of writing 7 as a whole number, I'm going to write 7 as a fraction. Remember that 7 floats up as the numerator because 7 divided by 1 still means 7. So now I'm going to go ahead and multiply my numerators. 4 times 7 is 28. 10 times 1 is 10. So 28/10 is an answer. But I'm always going to ask myself, is this the best answer I can give? First thing I'm going to look for, is this an improper fraction? Well, it is an improper fraction. And so we need to change that improper fraction into a mixed number. And so to do that, I need to really think about what this improper fraction means. This improper fraction means that I grabbed the tenths bucket and I pulled out 28 of them. And I want to figure out how many wholes can I make and how many tenths would be left over. That doesn't look like a 0 at all. That should be 10. We'll work on that, right? So I know my denominator is going to stay 10. So here's what I have. I know I have 28 tenths, and I know that I'm going to divide, remember that fraction bar is just a division symbol. I'm going to divide those 28 tenths into groups of 10 because every 10 makes a whole. So I need to ask myself, how many groups of 10 can I make out of 28? Well, we don't divide in our head. We use the mystery of multiplication. So I'm thinking 10 times what gets me close to 28 without going over? Well, 10 times 3 is 30. That's too high. So 10 times 2 is going to be my best bet. And that's going to land at using 20 of them. Well, I have 28, but 20 of them went to making those two wholes. So that means that I have 8 tenths left over. So my answer originally was 28 tenths. I rewrote that in a more understandable way by saying it's 2 and 8 tenths. That's easier for our brain to understand. So that's the I part of our IS checklist. Is this answer the best way to share my answer with the world? But then we need to ask ourselves, and again, this part is going to be optional, but I think you guys can do it. Is this in simplest form? Can I see one and done? Well, there's no numerator of a 1. The numerator and denominator are close, but they're not one apart. So this is when we would need to draw the F and see, are we one and done? Or can we simplify it? So I'm going to move my face yet again. I feel like I'm in the way. And I am going to list my factors of 8. We have our Captain Obvious 1 and 8. And then I know 2 times 4 is also going to be 8, and 3 times anything. So these are my factors of 8. These are the numbers I can divide 8 by. But I want to find something to Watudamadud the 10 by. Do the same thing to the 10. So I have to find one that works for the 10 as well. We always want to find the biggest one, the biggest hammer to hammer it down. There's nothing times 8 that makes 10. There's nothing times 4 that makes 10. But I know that 2 will work. So we're going to hammer down 8 tenths with the 2. I know 2 times 4 is 8, and I know 2 times 5 is 10. So what we just did was we simplified the fraction 8 tenths into 4 fifths. But let's see if we're one and done. Is my numerator a 1? No. Are my numerator and denominator 1 apart? 4, 5? Yes, they are. So I know that I was able to simplify 8 tenths to its simplest form of 4 fifths. So this is the hardest part. I have turned an improper fraction into a mixed number. Check. I put the fraction part in simplest form. Check. But if I'm going to tell Mrs. Phillips my final answer, it's got to be the whole shebang. We started with 28 tenths. We turned that into 2 and 8 tenths, but then we fixed the 8 tenths part. So my final answer is still going to have the whole number of 2, but the fraction part is 4 fifths, because that's the simplest way to say 8 tenths. Okay, if what you just saw does not clear it up, send me an email, okay? And have the title of your email say, raising my hand, because that will let me know you need some additional help and I'll reach out to you. You guys can do this, and if you can't, we'll work on it together.